So first speaker is Mr. Rohan Shende. He is founder of Ananta Dimensions. Rohan is a mechanical engineer by education. By profession, he is a hardcore techie. He is much passionate about 3D printing, spending his almost entire career so far in 3D printing, doing lots of research, doing lots of stuff into, and that's where his topic for today as well comes from, 3D printing in circular economy. We'll get to know from Rohan in detail. Rohan has built this company, Ananta Dimensions, where he's also providing, apart from his innovations, he's also providing 3D printing services and custom projects designing. So he's basically contributing a lot to the ecosystem of 3D printing in India. Welcome, Rohan. And next speaker is Madhav Bal. Madhav, again, as I said, we have a variety of speakers, variety of people in this ecosystem. So Madhav comes from a different background. He is a management graduate. Madhav is not a techie or a mechanical engineer like Rohan, but he comes from a family business background, and he's an avid reader, and he's a golfer as well. Mother worked with a lot of family business companies within their business, but he's an avid reader, and his inclination towards 3D printing came when he read about 3D printing and got excited about it, and so that's where he started his own company, i3D Innovations. And there they are providing, I would say they are the major player of 3D printing and dental lab solutions in the country. And Madhav today will be talking more on metal 3D printing in the second half of our session. Welcome, Madhav. So
thank you. Thank you for the introduction.
With this, I'll stop sharing and maybe we can just start with the first presentation of today.
Yeah. Yes. Thank you, Mudit, for the introduction. Good evening, everyone. You can see my screen, right, everyone?
Yeah.
Yes. And for everyone, while we presenters are presenting, if you have any questions, please feel free to put them on chat, and we can take it after the presentation is over.
Okay. So good evening, everyone. As they said, my name is Rohan, and working in 3D printing for last 5 years. And today I'm presenting a topic which is more called as 3D printing in circular economy. So before going into detail, we will see every aspect of this topic. So as we all know, familiar or we all seen what is 3D printing and how it's done. So it's majorly focuses on batch production, and theoretically, with the help of 3D printing, you can manufacture any complex design with the terms and conditions apply, of course, because it depends on the different types of technology. Because 3D printing as such theoretically don't have any limitations when it's come to manufacturing. But the technologies, different types of 3D printing has certain type of limitation. As we said earlier, some printers have a limited bed size, so that kind of limitations are there. But theoretically, we can produce any kind of geometry with the help of 3D printing. And of course, with the 3D printing, you can have parts in very short lead time, like within hours also. Again, it's depend on the technology, what kind of technology we are using. We can have parts printed in within hours, or mostly in couple of days, like 3 to 4 days. So basically 3D printing, as we've seen, it's a layer by layer process. It's a brick by brick process. But I always want to quote a line which is very interesting for 3D printing, which I found a couple of years back, which is 3D printing is going to be way bigger than what the 3D printing companies are saying. So what you're saying, what you're seeing right now on the internet or in actual, what 3D printing can do, it has more potential what currently it's doing. And by the time comes in the future, it will unfold its application day by day. And I'm hoping one day 3D printer can be a part of our home appliances also. That can be also possible. So future of 3D printing is very unpredictable. No one can just predict that this is going to be happen. Anything can be happen, and there are endless applications for 3D printing on each and every aspects of life. Then economy, this is a hot topic in right now, right? We all seen the crisis, Sri Lankan crisis, economic crisis. Then we see the fuel prices in India is higher, it's increasing. So it's all about economy. And the theoretical definition of economy is the area of production, distribution, trade, and consumption of goods and services. So as we see our daily life, we are the consumers sometimes, and we are the producers of sometimes, of goods and services also. If we are, consuming means our daily life, we consume a lot of materials also, or food, anything. But when we do our job, we create something, we produce some services. So it's kind of economy where we are living right now. So everything is connected to economy. And that economy has a lot of types, like linear economy, recycling economy, and the circular economy. So linear economy is nothing but it started, with the first industrial revolution happened after, because we started producing the goods at a mass rate. We are just producing, and we are using that product, and we are throwing that away in those era. That's called the linear economy. Because in the first and second industrial revolution, there is no loop cycle connected to the production, where we can recycle and reuse that. We never reuse that material again. We just used it, and after its cycle time, we just thrown it away. So in the initial stage of third industrial revolution, or at the end of the second industrial revolution, we realized that we need to reuse that part, because the plastic was the most used material back then, and still it is. So they realized that we need to recycle that also, because it's going to be end up on the landfill, and we are polluting the whole earth. So they introduced the recycling economy, and as you can see, the raw materials and production used, and we are trying to recycle, but everyone, all of us knows how much in our home also how we distribute our waste, and give it to the municipality, and how it gets segregated, and what kind of percentage it's get recycled. So on an average, 9% of the plastics only get recycled worldwide. All other plastics end up at landfill, or somewhere polluting the whole earth. So that model is still lacking. So now we are coming up with the circular economy. So here we are trying to eliminate waste at all. So again, this is a theoretical concept. While implementing it, it's going to take a lot of decades. But what circular economy is mainly focusing on is the materials that we use. So now you can see, in the packaging industry, they are coming up with the organic material which get biodegradable after the use. So now we are coming up with such material which has a zero waste possibilities. And again, in the coming future, we will use that materials in actual industry also. So that a shift is started for that circular economy, where we are trying to eliminate waste at all, and we are reproducing that material again and again. We are reusing that material again and again, or it can be biodegradable, so there will be no waste as such on the landfill. So this is a brief introduction of the circular economy. Circular economy is in such a different topic at all, but on a brief, I try to explain it. Then the definition of circular economy is a model of production and consumption, which involves like sharing, leasing, reusing, repairing, and refurbishing all the materials and products as long as possible. So because why it comes? Because of the global challenges like climate change and waste and pollution and biodiversity losses we are facing on in the sea. So there are three main objectives of circular economy: is eliminating waste and pollution, circulating the products and material as much as possible, and regeneration of the nature. And if we see, there are 5 elements of this circular economy, which is material, design, manufacturing, products, and end of the life. So these 5 elements we will see in 3D printing, and how it's implementing, how 3D printing is enabling this circular economy with the help of producing parts with the help of 3D printing. So materials, as a lot of us have seen the FDM 3D printing, right, where the filament is come into the hot end and it gets melted over there, and the nozzle deposited on the bed. So this is a basic and a cheap 3D printing, in the market, and we can easily have access to it. Anyone can have access to that technology. So in the technology, in that FDM 3D printing also, now there are filaments are coming, manufacturers coming up with the bio-based filaments. The filaments that can be degradable in water, that can be, compostable, bio-based, biodegradable filaments. So it's not like a plastic. They are a form of plastic, but they are made with the wood, starch, and food materials, natural materials. And also now we can use the recycled plastics also with the in a 3D printing, and it's again helping connecting to a circular economy, and we are kind of eliminating the waste, and we are doing the waste actually with the help of 3D printing. So that thing is there. And if we consider the conventional manufacturing, so conventional manufacturing in some industry, they need very lightweight parts, and the difficulty of that is there is very lightweight metals available. The one is titanium, which is very popular, and because of titanium only, 3D printing industry get boosted because they can process the titanium. So the application of 3D printing gets wider and wider. And of course, now there are a lot of material is coming in the metal 3D printing also. But what titanium is enable us is we can produce very lightweight part, because titanium is very light in weight than the aluminum. So and conventionally to process the titanium is very hectic with the help of CNC because of its heat resistance properties. But with 3D printing, we can process titanium very easily. So titanium was the game changer in metal 3D printing and all the 3D printing industry. As you can see the background picture, which is Bugatti's brake caliper. So the main body of that brake caliper is printed in titanium. It's a 3D printed part. It is they able to reduce the weight to the 30%, 30 to 40% is the weight reduction, and they can because of the lightweight, the whole assembly is lightweight, and they can achieve a more efficiency also. And the biggest advantage of 3D printing materials is now you can replace the aluminum parts also in the conventional industry. Like the same kind of strength you can get with the help of nylon, which is PA12, and we can process carbon fiber very easily with the help of 3D printing. And there are engineering material called like PEEK and Ultim, which has the potential of in the medical industry also. So these kind of engineering materials also we can with the help of 3D printing we can process and effectively. And because of that, we can reduce the carbon footprint also. And of course, these are the plastics, so we can reuse them very efficiently instead of metal, because metal takes a lot of energy to you get recycled. But in this if we compare with the plastic, we can recycle those plastics very easily if we have that kind of infrastructure. And as I speak, FDM 3D printing. So you have seen the material, heard the material called PLA, polylactic acid, PLA filaments. So they market that filament as an eco-friendly filament. Everyone knows it. So that filament, which is known as the eco-friendly material, in actual reality, it is not that much eco-friendly, because that is eco-friendly when you give it to a industrial waste management system. So then only it can get biodegradable, unless and until you have that kind of infrastructure, and then only you can process that material and compost it and then you can say it's eco-friendly. If you don't have that kind of infrastructure, which is not available right now in India, in all places, so that PLA, the eco-friendly material, also end up polluting the landfill, same as the other plastic is doing. So there is a loops, and by the time comes, we can have that kind of structures also, ecosystem also, where we can produce and we can compose that material very easily. But now filaments also coming, like bio-based filaments, as I said, we can directly compose it in a home environment also. So that kind of futuristic revolution is also happening in the material field for the 3D printing, specifically for the 3D printing. And in the coming coming days, we can see the 100% biodegradable filaments also and materials also for the 3D printing. Then the design. So to use the fullest potential of the 3D printing, what we can do in a design phase is we need to design it from the scratch for the 3D printing. Then only we can utilize that potential of 3D printing at its fullest. Because what happens when you take the conventional part and try to replicate it with the help of 3D printing, you will face a lot of challenges. Because that there is chances that that same part with the help of 3D printing will not function as it is used to be with the help of conventional manufacturing. But if you adopt the approach of design for the 3D printing, you can get much more efficient result for at the end of the day. Because sorry. Because 3D printing enable us, to have like lightweighting parts and part consolidation, where there is no need to assemble the parts anymore. There are use cases of in aviation and a lot of industries, in automobile industry also, where it used to manufacture 7 different parts and get to assemble for the function properly. Now you can reduce that 7 parts and 3D print the whole single part. So it can, you can't depend on the 7 different vendors as such. You can just produce part in-house from the one vendor also, and there is the less consumption also. So that mindset change at the design stage will help, organizations to adopt 3D printing at its fullest potential. Sorry. And then there is a term called design for additive manufacturing, where, as I said, you can design a part in such a way that you can achieve a part consolidation. You can, reduce the weight, optimize the design, and you can achieve more efficiency at the end. And again, there is two processes, to design that part, which is, one is generative design, and second is topological optimization. And generally, most of the people have, seen those parts, like the background, the motorcycle main chassis is like 2 or 3 different parts only. So it's a output of that topological optimization design. We can create such a part with the help of 3D printing, where less and less material can be used, and we can get the same efficiency that used to be get with the help of traditional manufacturing. And as you can see, those chassis, it is very hard to manufacture now with the help of conventional manufacturing, like tooling, like CNC and other machines. But it can be easily 3D printed in any machine. So that is the biggest advantage of 3D printing, that we can use less and less material, and we can create less and less scraps also. So that decision has to be made at design stage, so it can benefit at the end of that recycling that material also. It can be helpful if we change our mindset at design stage only. Then there is a manufacturing and products. So as all we seen, like in the pandemic, how 3D printed has helped a lot of hospitals to manufacture that face mask locally. A lot of people with the 3D printer in house started manufacturing those face masks for the hospitals, nearby hospitals, and they used to give those to the local hospitals. So, and it helps very that kind of potential was not there before, and we suddenly we seen some kind of potential with the help of 3D printing in the pandemic. And because of that also now, even the few days back, US also launching its scheme for adoption of 3D printing to its small scale industry. They are now giving some kind of scheme. They have launched some scheme for their industries. Also in India also, our technological department has released their future plans for 3D printing also. They have released their documents. So this kind of adoption is now there, and we will see in coming years that at every stage of the industry they're gonna introduce 3D printing. So because the advantage of 3D printing is it's digital. You don't need that much of space as such required, like a conventional factory required. The most of the thing is done digitally, and it's on-demand manufacturing, and we can distribute the manufacturing at a different location, and that kind of local manufacturing can be possible. So like the Maruti car, or if a Tata car used to manufacture in some remote location of the India, and it get distributed to whole India. So if something that happen in that particular region, so production will stop and we will suffer. We will not get our product on the time. But same thing if happening at a different location with the help of 3D printing. So chances of failure of one factory not affect the whole supply chain. So local manufacturing, local distribution, and on-demand manufacturing is very helpful with the help of 3D printing. And because it's on-demand manufacturing, we can actually go inventory less. So there are studies, and a lot of automobile players are also thinking about having a less inventory, and they can introduce a 3D printer at your service station. And what you can, if some parts is damaged, that service center will manufacture that part on demand with the help of metal 3D printing, and you will get the replacement. The biggest advantage is that they don't need to keep the inventory also. And if there is no inventory, ultimately it's gonna production cost also gonna get down, and you will have a less scraps also at the end. And because of the local manufacturing, there going to be a less shipping involved in that, so the less carbon footprint also is there. So these are the future scope, and it's also started implementing on the globe. And if you consider a product criteria or the element of this economy, so what 3D printing is enabling now is we are shifting from mass production, which is the third industrial revolution and the second and third industrial revolution, to a mass customization now, which we are saying now it's IP4, like Industrial Revolution 4. So in the fourth industrial revolution, we can achieve mass customization, where we are still using mass production techniques, but something we are delivering with the customized needs. We can deliver the customized needs also, and that customized needs we can achieve effectively with the help of 3D printing. Because you see, on a bed we can print multiple parts, multiple different parts at a time. So with the help of that scenario, we can produce mass customization parts at the same time. And if you see current jewelry industry in India or in a globe, so 90% of the jewelry industry use 3D printing only to prepare their masterpieces, and then it's get casted. So because that you can manufacture those with the help of that 3D printing. You can manufacture those different designs within a few days, and you can deliver that parts like within a week. So this is the biggest advantage of 3D printing for mass customization. And of course, you've seen the prosthetics also, that patient-specific prosthetics are coming now. So everything is possible because of this mass customization and 3D printing. So at the end of the life of the product, what happens currently is it is going to we throw it on a landfill. It goes there or some of the parts it gets recycled. But if you consider main 3D printing technologies which use like globally at large scale. They are FDM 3D printing, resin based SLA or DLP 3D printing, and there is a powder based metal and plastic. In plastic there is SLS and MGF 3D printing. These three 3D printing techniques we use at at larger scale throughout every nation on Earth. So what happens is that powder, as you know, if you know, we can reuse that powder for multiple times. But again, there is a limitation to reuse that powder. So there is 15 to 25% of waste at the end of the day for powder-based 3D printers. If you consider resin-based 3D printing, so that it's a for that resin gets cured with the help of UV light or a laser, and it's form a solid part. So that currently there is no such recycling techniques available, because that parts is once made, you can't reuse that parts currently. There is no such techniques available. So resin 3D printing is not closed loop system right now, or maybe there is no commercial product available to recycle that part. But if you consider FDM 3D printing, which is widely adopted, so there are few projects has been done, or commercial products are also available, in which what they do is with the help of your waste 3D printed parts or broken 3D printed parts or your support material, they try to make a filament out of it and then reusing it for 3D printing. But their main drawback of producing that filament is we are not able to maintain that diameter of the filament consistently. So because of that, again, when it's come to a extrusion of that filament, lot of failure happens because inconsistency of the design diameter of that filament. But that same FDM printed parts we can also recycle at the industrial waste, because it's the same plastics. Again, if we segregate it properly, we can recycle it with the help of other plastics also. And to tackle this waste part also, I am with my company Untitled Dimensions is working in particular FDM for working in a particular FDM 3D printing space where we can reuse the waste plastics for 3D printing. For that, we are approaching with the extruder directly. We are not into a filament making and then reusing scenario. But what we are trying to do is we can use that, we can shred that waste plastic into small pallets, and we can use that small pallets directly from the 3D printing. So we are developing that extruder here in our company, and it's called a pallet extruder. So as you can see on the left side of the screen, it's a basic diagram where the screw is fed that pallets to the hot end, and we can 3D print it. On the right side, you can see the pallets is a black color pallets is there, and they are going into the extruder. Because it's under development and we are trying to developing that, we can't show you its growth or its some clips or anything. But we are trying currently we are at a stage of we are able to extrude the ABS and HPDP and LPDP plastics. Currently we are at this testing stage now. Hope at the end of this year we are able to launch that product, or maybe a first quarter of the next year. So we are working in developing such kind of extruder for FDM 3D printing, where we can reuse that waste plastic, and again we can 3D print it for number of times. The biggest advantage of this extruder, pallet extruder, is it's a high production speed, because it is not a filament and small nozzle. We can actually extrude much more material in a volume as compared to the normal stock FDM 3D printing. So we can achieve higher speed also. And if you can see, the pallet, like the raw material, the filament. The filament is also in India. The filament cost is on an average 900 rupees for per kg. But if you see, just Google it, the prices of the raw plastics like pallets, it starts from 100 to 150 rupees. So 80% of the cost is in the making that filament, in the process involves. So we can reduce that per cost of per part cost of the FDM 3D printing also with the help of this extruder. And again, the second benefit of this pallet extruder is we can use the material which is available for injection molding also. So if you see the FDM 3D printing market and the filaments which are available, they are very limited, though they are growing day by day, but it still can't reach the place where injection molding is there. Like the wide material choices are there for the injection molding in. So every plastic has ever produced on this planet is injection moldable. The injection molding machine can use that plastic and prepare make the parts. But for 3D printing, it's very hard, to use every material, because we need a filament at the end of the day. And some pallets and some plastics are very hard, to make it a filament and put it on a spool, because they are brittle in nature and something like that. But with the help of this pallet extruder, we can use that materials also, and come up with different applications also. So that kind of thing is also possible with this pallet extruder. And yes, I think I'm done. I completed the everything, and that's it from my side.
Great presentation, Rohan. Thanks a lot for sharing those insights. And definitely that pallet extruder, whenever that is complete, it would be good to see when you market that product. Thanks a lot. We will take. I see on chat there is one question, but maybe we take it later on after Madhav is also done. Maybe we can have both the views. So Madhav, over to you for the next one.
Okay. Can you guys see my screen?
Yes, now we can see.
Okay. Okay, first of all, I would like to thank Mudit for organizing this webinar, and my fellow speaker Rohan for also for giving his thoughtful insights on 3D printing, as well as I'd like to thank all of you for participating. Basically my company, my presentation is on metal 3D printing. I'll just give you a brief introduction to what my company does. The name of my company is Innovative 3D Printing Solutions, NLP. We are an ISO certified dental lab based in Gurgaon, dealing with dentists and hospitals pan India. We use 3D printing as a primary method of manufacturing, using a combination of metal printers as well as DLP/SLA printers. Just to give you guys a brief overview of our manufacturing process, I've segregated it into three parts. Manual, which is something that we don't do, but about 95% of all the labs in India, I would say about 99% of all the labs in India do use the manual process. Then we have the semi-digital process, which is about 80% of our work comes from doctors, is done semi-digitally. I'll explain to you in a further slide what that means. As well as we have the fully digital process. Right. So when you talk about the manual process, this is what Rohan was talking about in the jewelry industry. What they do is basically, if you guys have ever, I'm sure you guys have been to a dentist before, they take a physical impression. That physical impression gets sent to us as a lab. We then, so we call that physical impression a negative. We turn that into a positive model using plaster of Paris and other materials. Then we do die cutting, stitching. Then we make a wax pattern by hand for the crown that actually needs to be manufactured. After that, we do investment casting or you can call it induction casting. Sorry, before that you do wax burnout, then you do induction casting, and then you do the metal finishing, layering and glazing, and then packing and shipping. Right, that is a fully completely manual process. The disadvantage of this is that the total amount of workmanship that is required, plus the total number of manpower required, plus the human eye, I mean, biologically, the human eye can't see less than 100 microns, right? But we have machines now, like our metal printing machine has an accuracy of 30 microns, which you couldn't in our scanner. I'll explain it in the next step. Our scanner has an accuracy of 10 microns. So it's not even comparing apples to apples. In our semi-digital process, you can see here now where the main difference goes is that we receive this is about 80% of our work. We receive the impression from the doctor. The first few processes are the same where we pour the model, but then you can see after the ditching process, we have lab scanners, right, where we scan the model. So it becomes a digital file. From being a physical model, it becomes a digital file. Then we design the prosthesis that needs to be made. We manufacture it either through, depending on the material, if it's zirconia, we do CNC milling. If it's a metal prosthetic, then we do, or a metal ceramic prosthetic, then we do it in our metal 3D printer. And then we do the finishing, and then we do the layering, glazing, and then we ship it out. So you can see automatically, just by adding 3D printing to our production, we've been able to reduce the total number of steps taken. And now this is a fully digital process where in the dental industry now we've got these things called intraoral scanners, which doctors themselves they keep with them, or sometimes labs, like we also offer the service where we take a scanner and we scan the patient's mouth directly. So we get a direct digital file that gets sent to us over email. So there's no travel either. And here is the interesting part, because we can do for metal ceramics, you need to do the layering. In the layering and glazing part, you need to basically that will unfortunately be a manual process for until they can automate it. Someone finds out a way how to automate it. But here, what happens is that we manufacture the prosthetic, plus we manufacture the model using two different printers at the same time. So you can see that the time and the total number of steps is decreased even more. And then the prosthetic gets finished. We do layering and glazing, and then we ship out the final item. So you can see from a total manual process to a semi-digital process to a completely digital process, you can see that the total number of steps is decreased in each step. I'll just play a short video about how what we had to do during COVID-19, because the pandemic. What happened when the pandemic? We all know that there was first lockdown and then curfews, right? But you still have to figure out a way how to execute the orders that you receive. So this is just a short video of our entire manufacturing process. It's a POV short video. Receive the order. Then we sanitize the order, because for us in the dental/medical industry, it was very imperative, especially during COVID-19, because everything was coming through the entire virus was being spread through the mouth. This is the ditching stage. This is where we convert the physical model. This is the scanner into a digital file as a CNC milling machine. This is our metal 3D printer. And then we do the layering, glazing, and then packing, and then we ship it off. right? So, next slide. This is just a short video about how the metal printer that we use is uses this technology called SLM, selective laser melting. It's also known as DMLS. They're both the same thing, but there's a company that has basically patented the name DMLS. So all other companies, even though it's essentially the same, it's the same technology, is known as SLM, selective laser melting, where basically, so this video has been slowed down, where you can see that there's a laser that's hitting the powder. We use cobalt chrome powder, which is a biocompatible material. This where the laser is hitting, that's known as the build chamber. The other side, where the other square on the right side is the powder chamber. So what happens is, this is one layer that's getting manufactured. What you will just see in a second is the recoater will take one thin layer of powder. The size of the powder particles ranges from 5 nanometers, 5 microns to about 5 to about 50 microns. Here is recoating another layer. This is again, as I mentioned before, in slow motion, and then the recoater it recoats another one layer of powder, goes back, and then it hits the next layer. So that's how we do layer by layer manufacturing, right? This is a video of the finished product. After we're done with the production, when we take out the parts, this is what it basically looks like. Skip a little forward for you guys here. The powder is very extremely fine, so you have to be very cautious at this stage when you're setting up the printer, and when you're finishing or when you're cleaning out the printer. You have to make sure that you're wearing gloves and masks and everything, because the powder is if it's ingested, it's very dangerous. That's what the final product looks like. As you can see, the bottom layer is known as the base plate, and each level above that was printed layer by layer. Right now, I'll be talking about metal 3D printing in general, and its different applications. So I'll be going industry by industry. But before that, I just want to give you guys a bit of a anecdote about how 3D printing actually helped us during the pandemic. We were basically, because of the curfews and everything, we were basically able to make our production process efficient in such a way, only thanks to 3D printing, where during the non-lockdown hours, when people were allowed to come to office, even though we had the permissions for people to come to office during post curfew, we thought that it would be safer for our people to come to office as less as possible. But we were between a rock and a hard place, because we had patients that had that had implants being put in, that were very critical. So we had to make a conscious decision to make sure that our people, our employees came in. They did their job as efficiently as possible, and the most helpful part about this was that we were able to run. Our machines didn't have to go home, right? We were able to do all of our. We were able to streamline our workflow in such a way that all of our manual processes were done during the day, during non-lockdown hours, and our machines were able to run during lockdown hours. So all the manufacturing that we did happened during lockdown, and all the pre-processing and post-processing happened during when we had the window when we were able to come and work. So it was very beneficial. Yeah. So now coming back to metal 3D printing in different industries. In the medical industry and what we do in the dental industry, it's very similar, where we create patient-specific implants or prosthetics. You can see in this image, this is actually a part that I have that we printed ourselves in our machine. It's a bone plate, and that is, so these are two different 3D printed parts that have been printed in tandem with each other, as I mentioned, in the fully digital process. But for us, it would be in dental, it would be a model. Here, this is a bone plate, which is a medical implant, patient specific, and it's designed especially for this particular. You can see how the grooves have matched this collarbone, right? So this is a collarbone, and this is a bone plate that's been designed for this collarbone. You can see that it's here, and it's in two separate pieces, and it just fits basically like a glove, right? As Rohan was mentioning earlier, that you can print multiple parts. The benefit of this technology is that you can print multiple parts together, customized parts, mass customization together. I have two base plates. This is one base plate. Each of us, for us in the dental industry, we know that each of us have different bone structures, different jaws, different teeth sizes. So we're able to print for multiple people. We're able to print multiple prosthetics at the same time in one shot. Right. Similarly, I have another base plate here where we have different medical implants. Right. You have an acetabular cup. You have a spinal cage. You can print all of these parts in one shot. So you're saving a lot of time. And if you need to do reiterations, it's much easier because you're not wasting that much material. If it doesn't fit, you're quickly able to find out what the issue is, and then you can make the changes accordingly. Next, we get to aerospace. This is something that interests me a lot. Here you can see that in the aerospace industry, they started to use 3D printers and the different types of 3D printers. And they've been able to see the benefits of it. Like, for example, here they're printing an entire rocket nozzle. Now, during the Apollo moon landing missions, they had to basically build the entire part piece by piece in different parts, right? So what happens in a rocket? This is known as a D-level nozzle, right? This is basically a very, very hot. This is where all the hot exhaust comes out of, and it's very imperative that this doesn't melt. And there are no metals that exist. There are no materials that exist that would stop that from happening. So what they had to do during the Apollo missions was that they had to make little strips where they would flow the rocket fuel itself through the on the outsides of the rocket nozzle, because the fuel was cryogenic. So that helped basically keep the nozzle from not melting and destroying itself basically. So what they had to do during that time was they had to weld basically individual strips where the fuel would go through the nozzle, and then come back into where it would get injected and then get converted into exhaust. Now, what companies like SpaceX, there's Rocket Lab, there's Blue Origin, these companies are now basically seeing that you can now 3D print these rocket engine parts. And there are some companies that I'm forgetting the name. Like SpaceX, the new SpaceX Raptor engine is the Raptor 2 engine is about 95% 3D printed, right? Including the batteries and everything are all 3D printed. Everything is done through 3D printing. So it's getting more and more recognized, and people are seeing the advantages of it in different industries. Okay, this is the one gentleman had asked a question about the size of the printer, right? Where you can only print a certain size. Now, innovations are coming up every day. This is basically this company called Relativity Space, where they're using a different type of metal 3D printing. You can see that there's no powder or anything used. This is very similar to FDM 3D printing, which Rohan talked about. But in this, instead of using a plastic filament, they're using a aluminium filament. They're using an aluminium wire actually, and they basically take electricity and they melt the wire at just above its melting point, and they deposit it at each part. So they're using robots. They're using a mixture of robots plus 3D printing to create large, much larger structures. Like for example, they're printing the entire like for example, this entire part, the entire fuel storage is this one piece, and this entire piece has been printed in one shot using robots and 3D printers. This type of 3D printing is known as direct energy deposition, basically. So where they basically they use a wire just to melt it above the heating point, and then it just goes layer by layer by layer. This is, I think, this GIF or GIF, however you pronounce it, is a very it gives you the idea of how 3D printing is actually done, in different types. Then next, the last thing I would like to talk, industry I'd like to talk about is the automobile industry, which again Rohan had mentioned before. This car in particular is the one I'm going to talk about. This is known as the Koenigsegg 11, was the world's first hypercar. It's called the Koenigsegg 11 because its fuel to power ratio was 1:1. That means it weighed 1,370 kilograms, and its power output was 1,370 horsepower. Now, they were only able to do this because through 3D printing. And how? This is the turbo that this car has two turbos. It has two turbochargers. So this part was completely 3D printed, and they were able to make the weight, reduce the weight of the turbo, reduce the size, make it more efficient only by 3D printing. Because if they had any issues with the thing, if it was too heavy, if they wanted to reduce the weight, as Rohan mentioned also before about design optimization, they were able to do that only because they were able to print the part, test it out. If there was anything wrong with it, they would make the changes in the CAD system, print it again, and then keep reiterating till they found perfection. And then I think this is the closest anyone ever. It was, as I mentioned before, the world's first hypercar. So us at i3D, we are basically in the dental industry for right now. We will be soon moving. We will be adding another vertical of getting into the medical industry. There's a few more hurdles for us to get into that in terms of certifications and everything. But all the materials that we use are all sourced from Europe. They're all CE certified, so there's no issue with that. But for me personally, I would like to do something similar to what people at like SpaceX and Relativity Space are doing by creating rockets. Because I also believe that we need to be interplanetary species. Humans cannot purely survive on one planet, and we need to be able to emigrate that. And the only way to do that is by doing it fast and cheap. And the only way to do that is through 3D printing. Thank you.
Indeed, Madhav, we all are interplanetary species, and we must design rockets with Indian ecosystem of space growing day by day. And I think you, with your vision and likes of others as well who are into 3D printing would be a big contributor to the space in India and to the world community. Thanks a lot, Madhav, and thanks, Rohan, for your insightful presentations. Floor is open for questions. If anybody is having any question and want to ask a question on voice, please raise your hands. Or if you want, or if you're not very much comfortable asking, just type it on the chat and then we can take it up. Meanwhile, I already see one question from Deepak Garg. Are there any material dependencies in design for AM? So design for AM, any material dependencies? Yeah. Who would like to take that?
Yes. So we can see that from two perspectives actually. So if you're trying, as I said, if you're trying to, replicate the same part with the help of 3D printing, of course, there is a dependency of material. So there are less material choices for that particular design. But if you design such part for 3D printing, then you can use different materials also. If you want to replace the aluminum, same part with the aluminum with the help of 3D printing, and if you're considering, printing it part with the aluminum only, so it may cost you more than the conventional manufacturing, that part. But if you redesign that part and you can able to print that part with the help of carbon fiber or nylon carbon fiber, so you can get same kind of result, and the cost is also lower than the metal 3D printing. So it's depend on how your approach also and your let's say cost also, because at the end of the day cost matters. But because 3D printing is still new and the more and more material will come, but the existing 3D printing is kind of, you can say, for the Indian market is quietly costly. So that's why your approach is important in this scenario. How you are able to redesign that part for 3D printing, or you just want to replicate that part with the help of 3D printing. So the approach is what its major role in that.
I'd just like to add to what Rohan is saying is that it is also completely dependent on the application. Your material dependency for a medical implant has to be biocompatible. It has to be 100% biocompatible. You cannot print a part you cannot print a medical implant that is not biocompatible. Similarly, if there are applications that require a high heat load, you need to use materials that have high heat resistance, right? So it is completely dependent on the application what your material dependency would be.
That takes me to one question, Madhav and Rohan. With respect to a material and the corresponding type of printing, when we are designing, especially the curves and the overhangs, or what we call in different technologies, and the supports. So are there any dependencies with respect to, for example, if I am creating a rocket engine in metal 3D printing, which is an actual, versus if I want to create a small prototype of it or a scale model into a plastic or PLA printing or a PEEK, will there be any changes in the design, or I can just scale that design directly and put it into a printer?
Yeah, you can scale it down. It's just as long as you have a CAD file, you can scale it down. Just different printing technologies have different accuracy levels.
Mm-hmm.
Like for example, SLM has an accuracy of around 30 microns. So, but I think FDM is still limited to about 100 microns, approximately 80 to 100 microns. So your surface roughness would be a little different. But I mean, if you're just looking to scale down, if you're not going to be using it for an end case, if you're just going to make a model out of it, you can use it in different. I mean, you can use different materials and different technologies for different applications.
Thanks for the answers. Deepak, I don't see you have a voice activated. If you want to say anything more, you can just type in the chat. Meanwhile, moving on, and although also respecting the time here, Ayush Tyagi has one question. What kind of wastage is there in metal 3D printing?
So funny story, I gave a webinar with the company that we bought our metal 3D printer from. And one of the other guest speakers was a person from this German company who just so happened that we also use the material. They manufacture metal powders. It's this company called Schaeffner. He said, he said, and I'm quoting him here, that officially you're only allowed to you should be only using the powder once and then disposing of it. But he said unofficially you can use it as many times as you want. I'm telling you from my own personal experience. We use our metal powder till we use it as many times as as many times as much powder we have, we keep reusing it, recycling it. You have to filter the powder to get rid of the semi-sintered or unsintered parts. But but I would say on average 95% of the powder is reused. We have approximately a 5% wastage.
That's really good. Okay, I think we have one more. Uday, are there any options available for remote scanning? Very interesting one.
What type of scanning are you talking about?
Uday, if you could unmute yourself.
Because I know there's a company known as Shining 3D. It's a Chinese company. They have handheld scanners where you can basically scan. I mean, there are applications where you can do it on your iPhone also. It's not there on Android yet, but there's an application on iPhone. I'm forgetting the name, where you can just scan. You just have to scan it using your phone camera and convert that into a 3D model.
I think. Okay, so Uday says basically for the consumer product customizations, the scanning, which the question is asked, like the iPhone types with good quality. So I think yes, we have some good apps available, some paid apps as well available. But please, looking forward for your comments.
I will add to that also. For scanning nowadays, what is happening is software is coming, so there is no need to fully scan the part also. Like so for medical industry also, like if you take the example of hand or your leg, so there are certain major dimensions you require to put it onto that screen on that software, and it will create a general file for your prosthetics also. So with the help of that machine learning and AI also, they are developing such kind of softwares also in the future. So there is kind of less need of actually scanning the part. With just the help of your dimensions, basic dimensions, you can create a 3D model directly. So these developments are also happening like that. And of course, in the future, you can use your mobile phones also, for accurate scanning. They are not far. Like in couple of years also, we can see that your Android and Apple mobile also you can use for the general scanning purpose.
All right. I think we are already 8 minutes overshooting. But from all the guests, if you have any more questions, please do write to us and we will get the best answers to you. And thanks a lot again, Rohan and Madhav and all the listeners for being here, patiently listening and watching. And please do give your comments and feedback, a simple email. And keep learning, keep sharing, and keep growing. That's where 3D culture brings in all the experts. Till the time we meet again for the next webinar or a panel discussion, we will be sending out the invites shortly. Thanks a lot for joining.
Thank you, everyone. Thank you everyone for attending. Thank you, Mudit, again for setting this up, and Rohan also for speaking.
Yes.
Hope everyone had an insightful session today.
Yes.
Thank you. Thanks a lot.
Yes.
Thank you.
Have a great weekend.
Yeah. Take care, everyone.